Obtain the mesh file and the full training movie via this link.
In this project, we will simulate and analyze the flow of a particle trapping mechanism called the discrete phase trapper. In order to simulate the particles, the discrete phase model is activated, and Safran lift force and pressure gradient forces are also applied to particles. Also, since the trapping mechanism mainly works with gravity, the gravity has been taken into account. The flow containing continuous and dispersed phases enters the computational domain with a speed of 5 meters per second, and standard K-epsilon model is exploited for solving fluid flow equation. The geometry which you can see in this slide is designed in ANSYS Design Modeler software and includes an inlet and outlet on each side of it. The mesh type used for this geometry is unstructured, and the element number is equal to 420,485. In the appeared window, under the injection name, you can see the name of the injection, and also in front of that, under the injection type, you can see that the type of this injection is defined to be on the surface. By clicking on the surface, a new part will appear in front of it, which shows you the release from surfaces, which in this project, the inlet surface is defined. Also, the particle type is defined to be inert. Actually, the inert particle is a discrete phase element, which can be particle, droplet, or bubble, that obeys the force balance. Also, the material of the injection is said to be cold, which you can actually define the material in the material section, which will be explained for you in the next slides. Also, under the point properties tab, you can see different variables of this injection. For example, you can see the diameter, velocity, magnitude, and total flow rate of the discrete phase. It should be noted that inject using phase normal direction is enabled. As you can see, the gauge pressure defined for this boundary is 0, which means that the flow exits to the atmosphere. Also, again, by clicking on DPM tab, you will be able to see the boundary condition for a discrete phase for this boundary. Now, in order to see the particle tracks, you just have to click on particle tracks under the graphics section, and a new window will appear. In the appeared window, under the color by section, you just have to select the particle variables, and under that, you just have to click and select particle residence time. After that, you just have to select the release from injection, which we have selected inlet, and then click on save and display. Now, after selecting and defining the geometry you want to show, you just have to increase the transparency of the geometry so that you can both see the geometry and particle tracks at the same time. Finally, the summary of different settings and setup that we have used in our project is presented to you in the slide.
Obtain the mesh file and the full training movie via this link. To benefit from Master CFD services including simulation, consultation, and training, contact our experts via info@mastercfd.com.